Hello. In this activity, you're going to investigate the forces on charges moving in a magnetic field. The diagram on the right represents a region in a vacuum or low-pressure gas. Particles with a chosen charge, mass, and velocity can be projected into the box where a magnetic field is set up. The magnetic field can be in a direction that is into or out of the plane of the diagram, and its size can be altered. Lines of magnetic force into the diagram will be represented by crosses, and lines out of the diagram towards you will be represented by dots. The four sliders here allow you to change the size and direction of a flux density B, the size and polarity of charge Q on the moving particle, the size of velocity v of the particle, and the size of mass m of the particle. Let's drag the flux density slider to the left to select a relative value of -1. Note the crosses that appear in the box. What is the direction of the magnetic field? Yes, the magnetic field lines go into the diagram. Let's click play. And notice a stream of uncharged particles with a relative mass of 1 unit are projected into the magnetic field with a relative velocity of 1 unit. Let's click pause to stop the particles and click back to remove them. You will see that a blue track remains visible. Now let's give our particles a charge by dragging the charge slider to the relative value of +1 unit to project the particles into the magnetic field. What happens? Yes, the particles follow a circular path while they are in the magnetic field. The stream of positively charged particles moving from left to right is equivalent to an electric current in that direction. Try to apply Fleming's left-hand rule to the picture. Your thumb will point in the motion direction, which is upwards. Your first finger must point in the field direction into the picture, and your second finger must point in the current direction, which is left to right. Select force to show the direction of the force on the particles. You will see that the force only acts when the particles are in a magnetic field, and it's always perpendicular to the track of the particles. The effect of this force is to make the particles follow a circular path.